Welcome to the Infineon webinar introducing our latest generation of thinQ silicon carbide diodes, the 660 volt generation 5. This presentation will start with a brief description of the major benefits of silicon carbide versus silicon diodes. In the second part, the 650 volt generation 5 main features will be presented, together with a clear view of its positioning with respect to thinQ families of diodes already available on the market. A description of the benefits of wafer thinning, here implemented at industrial level for the first time, and direct measurements showing the improved efficiency level of this latest SiC diodes generation will follow. We will conclude with the overview of the planned portfolio. Thanks to the basic properties of this wide bandgap material, such as the very high critical electric field and thermal conductivity, it is possible to realize silicon carbide Schottky barrier diodes at voltage levels way beyond the actual silicon limits of around 250 volts. On the market today, we have in fact silicon carbide Schottky barrier diodes up to 1700 volts, and basic studies indicate that even higher voltage levels can be reached. Schottky diodes are majority carrier devices and as such do not show any recombination current in their switching behavior. This translates in extremely low switching losses. The switching losses depend on the amount of charge stored in the device and is proportional to the area bounded by the negative current and the x-axis in the graph on the right. This is relatively high for standard pin diodes, becomes smaller for high-end silicon double diodes, and nearly zero for silicon carbide Schottky diodes, where only a small capacitive displacement is still visible. Moreover, the switching behavior of silicon carbide Schottky diodes is independent from a number of application-related parameters, like forward current, the switching speed and temperature, which is not the case for silicon devices. These key features translate in a number of benefits. First of all, an improved system efficiency coming from both the negligible SiC diode switching losses and the reduced losses of the MOSFET in a typical PFC application. Thanks to the much lower current injected from the diode, which also contributes to reducing the overvoltage of the switch during the turn-on. The overall lower power losses allow reducing the cooling requirements and accordingly provide the possibility of increased the system power density. The adoption of SiC diodes reduces the EMI level, thanks to their very smooth behavior. Last but not least, the very stable switching behavior of these devices, independent from main system parameters, contribute to increasing the whole system reliability. Silicon carbide diodes are nowadays of common use in a number of applications. High-end server and telecom SMPS were the first to adopt SiC devices, and we have seen in recent years an increasing penetration in other fields such as solar, UPS systems, PC power and lighting. In this slide we would like to outline the relative positioning of the different families of thinQ diodes in terms of price and performance. Infineon has been active in the silicon carbide market since 2001, when the first thinQ generation was launched. In 2005 we launched our generation 2. The major advance of generation 2 over the first diode generation has been the introduction of a so-called merged pin structure to enhance the device robustness against surge current. This merged pin structure concept consists of regularly distributed p-doped areas in conjunction with the pure Schottky ones. In this way, during normal operation, the diode behaves like a Schottky one. But in case of high current spikes, the bipolar component is activated, and this dramatically reduces the associated voltage drop and accordingly the dissipated power. In 2009, we launched our Generation 3. This is based on the same Generation 2 technology, but with the introduction at package level of the Infineon proprietary diffusion soldering, which allows considerably a reduction of the thermal resistance per chip area. The Generation 3 has not been conceived as a simple follow-up of Generation 2, but has been tailored to create a new family of products with extremely low QC and therefore very good light load performance. Though slightly below Generation 2 at mid-full load, Generation 3 offers clear price benefits and represents the ideal choice for all applications where light load efficiency is in focus. Generation 5 takes advantage of all former improvements and introduces on top a new, more compact design and so-called wafer thinning technology. The main characteristics of the new generation are Voltage breakdown increased from the 600 volt level of the previous generations to 650 volts. Improved efficiency levels thanks to the lower figure of merit, VF times QC. The reduced wafer thickness resulting in both improved surge current capability and thermal behavior. The extension of the portfolio up to 40 amps and the introduction of new packages such as the TO247 and thin-packed ones. Last but not least, a lower pricing than Generation 2. Let's review them in more detail, starting from the benefits of the wafer thinning technology. The figure shows the cross-section of a silicon carbide Schottky diode. The drift layer in yellow is responsible for blocking the reverse voltage. The green layer is the substrate, responsible for giving the mechanical stability for the diode, but that also acts as a resistance for the forward current. In Generation 5, the thickness of the substrate has been reduced by 2/3, resulting in lower differential resistance for the same chip area and therefore a lower forward voltage. This results either in lower conduction losses with respect to Generation 3 due to lower VF and lower switching losses with respect to Gen 2 due to lower capacitance charge. In system efficiency, Generation 5 devices are providing the best efficiency across the entire power range. Besides reducing the electrical resistance, thin wafer technology also reduces the thermal path between chip and the package. In combination with diffusion soldering, this considerably reduces the device thermal resistance and guarantees operation at lower temperature, as shown in the thermal simulation. From Generation 2, thick wafer with soft soldering, to Generation 3, thick wafer with diffusion soldering, and finally to Generation 5 with both diffusion soldering and thin wafer. To confirm this, we tested the newest Generation 5 devices in a boost PFC circuit and compared them with Generation 2 and Generation 3. The PFC circuit maximum power is 1.8 kilowatts and the switch, a CoolMOS from the CP family, was switched at 65 kilohertz. The total system efficiency is above 98% for all families, but the relative efficiency shows what was predicted in the previous slide. For lower power, Generation 5 has the same performance as Generation 3 due to its lower switching losses. As the power increases and conduction losses play a major role, Generation 5 presents a comparable performance to Generation 2. For the entire power range, Generation 5 has the highest efficiency. In this last session, we present our planned product portfolio. It is first of all important to remind that all Generation 5 products are rated at 650 volts. We have a high granularity for the widely adopted TO220 package from 2 up to 20 ampere to ensure the best fit for your application with the most different requirements. We introduced for the first time in this voltage range the TO247, hosting the high current portion of the portfolio from 10 up to 40 ampere. 2 up to 12 ampere will be offered in D-squared pack, for the first time available in real 2-leg version, increasing the package reliability level thanks to the high creepage pin distance. With the clear aim of complementing our offer of CoolMOS 650 volt products, we're going to release SiC diodes in thin pack, a high performance package thanks to its leadless and form factor characteristics. Please check the single product status and availability on our dedicated website, where you will be able to find all brochures and related information helping you to design in the new 650 volt silicon carbide thinQ Generation 5 diodes. Thank you very much for your attention. In case of questions, please do not hesitate to ask our sales representatives, who will try to support you both commercially and technically in the shortest time.